What's up? Today we're working on a synthesizer. You want to watch me fix it? I bet you do. Otherwise you wouldn't have clicked on the video. Today we're working on a Korg microKORG. It's got a broken power switch and it needs a power supply and it doesn't have a battery door either. So we're going to try to fix all these problems. Stay tuned. So when this popped up secondhand at a good price because it had issues, I snapped it right up. I have always wanted a microKORG because they're pretty inexpensive and they're still pretty powerful, and they have a vocoder that I've always wanted to try. So hopefully we get this fixed up and I get to show you guys that. So first we need power for our microKORG. If you look at the back of it, it has a barrel type connector on it, so we know we're going to be looking for a wall wart type power supply. With those kinds of power supplies, there's 5 things you have to look out for to get the right one for your device. Number 1. What kind of voltage is coming out of that power supply? Is it AC voltage or is it DC voltage? That's alternating current or direct current. You have to get the right kind. Number 2, if the output of your power supply is DC voltage, you need to make sure you get the right polarity. Most of the time on those wall wart power supplies, the center contact is going to be the positive connection and the outer ring is going to be negative. But there are some devices that require the center contact to be the negative contact and the outer ring to be the positive contact. For instance, most guitar pedals require a tip negative power supply. Third, we need to know how many volts are coming out of a power supply we're considering using. We need to match that exactly to the device we're trying to power. If we have a device like this that requires 9 volts, you look for a power supply that provides 9 volts. No less, no more. The fourth thing we're looking for, minimum current requirements. We have to have a power supply that is able to push a minimum amount of current. How many milliamps or amps does your device need? Remember, there's 1,000 milliamps in an amp. So if you see a power supply that says it's capable of up to 1.5 amps, that also means it's capable of 1,500 milliamps. Remember, you can use a power supply that provides more current than is necessary, but don't use a power supply that can't provide the minimum number of amps or milliamps required to power your device. Last but not least, the power connector on your power supply needs to fit nicely into the power socket on your device. The outer diameter and inner diameter of those barrel power connectors can vary in size, so watch out for that. You got to make sure it fits in your device and makes good contact on the sleeve on the outside and the tip in the middle. You can see next to the power connector on the back of the microKORG that it indicates 9 volts tip negative power supply, but it does not indicate that the microKORG requires 600 milliamps worth of current. So I dug into my box of power supplies and I found this. This is a 9 volt power supply that is capable of up to 1.2 amps or 1200 milliamps, but it's tip positive. So that's the first thing that we're going to change. So on this power supply, you can kind of see that the 2 wires are stuck together as 1 wire. So basically what I'm going to do is I'm going to create a break, and then I'm going to flip these 2 wires on one side, reconnect them, and then we'll have a tip negative power supply. I'm going to cut off about 8 inches back from the connector. So I'll start by separating these 2 wires, and then I should be able to just peel them apart. I'll do the same thing to the 2 wires on this side. Now I'm going to flip one of those and I'm going to put them right up next to each other, and I'm going to create an offset. I'll cut this top wire at the end of this one, right about here. And I'll cut the bottom wire at the end of the wire on the opposite side. Now we've got something that kind of looks like this. Okay, so now we're going to strip and tin these 4 wires. And I'm stripping off about 1/4 inch. We can see here that it's a multi-strand conductor. I'll twist all those strands together. I'll use my helping hands to hold the wire still while I'm working. Then we'll take our 6040 rosin core solder and we will tin these 4 wires. And tinning wires just means you coat them with a little bit of solder. First I'll heat the wire, and I will apply solder in between the wire and the iron, and then it just adheres to the copper. If you're only soldering one or two things, it's probably fine to do it indoors, but if you're soldering a lot and you have a lot of fumes, you probably want to do it outside or somewhere where you have ventilation or a filter system. Now before I solder these wires back together, I need to insulate them to make sure that they don't accidentally touch each other and short out. I'll be doing that with a couple pieces of heat shrink tubing. First, I'm going to put this thicker gauge heat shrink tubing over both of these wires on this one side. Then I'll take this smaller gauge piece of heat shrink tubing and that will go over the long wire on that same side. So now we're going to reconnect our wires, making sure to reverse the polarity. So I've used my helping hands to carefully position the wires right next to each other. I'm going to clean the tip of my soldering iron. I'm going to put a little solder on the tip of my iron. I'm going to use that to fuse those two wires together. Now you want to make sure you do that quickly, because if you're on there too long, the heat from your iron will travel up the wire and could shrink your heat shrink before you want it to. Same process for the other two wires. So now you can see why I cut one of the wires short on either end. When I put them back together, it creates this stagger, and the two solder points have a little gap between them so they don't touch each other and short out. Now, just to be safe, I'm going to put this extra piece of heat shrink over the top of one of those solder points, so there's definitely not going to be a short on the inside of this cable. So now I'll use my heat gun to shrink the heat shrink. Now I'll take the other piece of heat shrink and cover the whole thing. And then we'll shrink that down. Now remember, when you're using a heat gun, don't put your hand too close to the front of the heat gun, and don't touch this metal part because it's really hot, and when you put it down, don't put it on top of anything that could melt or burn. I might have used black heat shrink if I wanted a cleaner look for this, but because I'm modifying this power supply, I actually wanted to use a bright color here to draw people's attention, to let them know that the polarity on this has been reversed. I'm also going to relabel this power supply so people know what the new polarity is. Now, using my digital multimeter, I will test to make sure I haven't accidentally created a short between the sleeve and the tip of the power supply. I'll set my digital multimeter to continuity, make sure the meter's working. So we'll take one probe, put it on the sleeve of the connector, take the other probe, put it on the tip of the connector. Now it beeps for a second, but you can see from the meter I'm measuring 340 some odd ohms in between these 2 points in this circuit, which means there's some kind of electronics between these 2 points and it's not just a 0 ohm direct connection, which is good. So now let's check the actual voltage and polarity. Set my multimeter to DC voltage. Black probe, our common ground probe, goes on the outside sleeve. Red probe, checking for voltage on the tip. And our measurement is negative 9.15 volts DC. Perfect. So we've got a good working power supply. I will put that to the side, and then I will get working on the power switch. First, I'm going to put down a towel, and I'm doing this because when I flip this over to take the screws out of the synthesizer, I'm going to be putting the weight of the synthesizer on top of the knobs and controls and stuff, which can be fragile. I don't think this is particularly fragile, but no reason to take chances. Keep in mind, once you've opened up a piece of equipment, it's going to void your warranty. So if it's a relatively brand new piece of equipment and it's got some kind of problem, it might still be covered under warranty, and you can just send it into the manufacturer and have that fixed for free. It might take a little while to get it to them and have them look at it and then have them send it back and that sort of thing, but you'll be having it fixed by the people who made the thing for free. Now, if it's not covered under warranty and you're handy with tools, you might as well open it and try to fix it yourself. Fortunately, it looks like we're working with standard Phillips head screws to take this apart. Now, this is an older synthesizer and it is made of soft plastic, so we're going to go slow, we're going to go easy, we're not going to tighten anything too tight. So let's keep that in mind when we're working. And I'm going to remove all the screws in this bottom panel. So if you think you've loosened all the screws on a panel and it's still not coming off, Don't try to force anything. You don't want to break the panel or bend it or anything like that. There's probably a latch somewhere, or there's some more screws that they've got in sneaky little hiding spaces. A couple places you want to check for screws is underneath these labels or stickers. Sometimes there'll be an additional screw, so you can run your finger back and forth, and if you feel a dip, that's probably an indicator that there's a screw underneath that label. You'll have to peel it back or break through it to get to that screw. Also, you may find screws inside of battery compartments, so take the lid for the battery compartment off, look for screws in here. There might also be screws underneath or inside the rubber feet on the bottom of a piece of equipment, so check there too. All right, it feels like our bottom panel is loose, so let's just gently and slowly lift this up. There we go, take it one little step at a time. Make sure you don't lose the screws. You're gonna need the screws to put it back together. Don't lose the screws. Now go slow with this, okay? If you feel it come up, don't just pull it apart, because there's probably, yeah, see how there's a battery compartment here? That is attached to the inside with a cable. So if I yank too hard, too quickly, I might break whatever cable's here. So I'm gonna disconnect. This has a little connector here. I'm gonna disconnect that power cable from the battery compartment. And then I'm gonna leave all those screws in the bottom panel and set that aside so the screws can just sit in there and they can not get lost and just stay where they're supposed to go. So now, up here in the top left, we can see our power switch. And that is what is going to get replaced. So we're looking at the top of this circuit board. I need to be able to get to the underside of the circuit board. I probably should start by disconnecting all these wires. We'll start by disconnecting this wire on the left. On this side of the wire, it is soldered into this circuit board, so I'm gonna leave that side alone, because on this side of the circuit board, there is a connector. So I will be, it's kind of a long connector. I'll grab both kind of ends at once and just kind of rock it back and forth and apply gentle but firm, if that makes any sense, pressure up, and then that connector comes off. So now that's disconnected. Same issue with this wire here, this set of wires, this multi-pin connector. It is soldered into the circuit board on that side, and then there's a connector on this end. So I'm gonna grab that connector and just kind of gently rock it back and forth and try to apply even pressure on the left and right hand side until it pops out of socket. There it goes. We've got another wire disconnected. Looks like we've got our modulation and pitch control connected with this little rainbow set of wires over here. So that goes to this connector. We're going to disconnect that. And oh, make sure you don't yank out one side but not the other, because you'll end up bending the pins, so be careful about that. And then that one comes out. Now I need to get the circuit board out. We've got a few screws on the circuit board itself. We've also got a few screws on the back panel here, so I'll have to take those out as well. Hopefully, as I'm taking the screws out of this circuit board, they're all going to be the same size and length. If they're not, I need to make note of that and make sure that those screws go back in where they came out of. Otherwise, it's not going to assemble back together properly. There's one here. And one here. Okay, I think I've got all the screws out of the circuit board. Now there's some controls and connectors that are attached to this main circuit board, and those are screwed to the back of the keyboard. So I'm going to remove those screws next. All right, we got all the screws on this side. We got all the screws on the back panel. I'm going to flip this over. And now on this side, it looks like we got 4 screws, 1, 2, 3, 4, and we're gonna have to remove all of these knobs here. I'm just gonna start with the knobs. Equal pressure on both sides of the knob as I'm lifting. You don't wanna like yank it from one side and snap the knob. Some of these, the shafts on these controls are, yeah, this is plastic, so that's gonna be more fragile than if it was a metal knob. Oh, that one came off nice and easy. All right, these are what's called knurl shafts. This last one on the right's being stubborn. I might have to figure out a way to use a tool to get it off. I don't want to break it. Oh, here it comes. Maybe? No? Come on, little guy. Okay, I've got these tools. They're basically just pieces of plastic. One's got kind of a lever and the other one's basically a thick guitar pick. We're gonna just use these to get under both opposite sides of this. And come on, baby. Come on, baby. Boy, somebody glued this on here or something. I don't know what to do. Oh, I got it. The knobs for these next two controls are actually bolted on. I'm gonna have to remove that bolt before I can pull them off. So for this, I'm gonna need an Allen wrench or a little screwdriver with a hex bit. Now I have 3 controls that have metal shafts and nuts on them, so I'm going to have to remove these nuts. You can remove these with a wrench or pliers or something, but the best tool to not scratch the device is probably a socket. There's a washer we'll take off and make sure we don't lose. The screws in the 4 corners are going to be hex screws. We're going to remove those with my little screwdriver. Okay, so this is a bolt that went into some metal, so you can see that the threading on it is finer than the screws that were going into the plastic. It still hasn't come out yet. Oh, it moved. Okay, I removed the top plate. Cool. Ew, grody. Yeah, I'm gonna clean that later. With a little bit of gentle encouragement, it started to move. So at this point, I'm going to gently encourage this edge of the circuit board up and out and pull it this way towards me and up. And that is so these controls and connections here are able to lift out of the holes that they've been pushed through and then out of the device. So let's get this cable out of the way and this cable out of the way. And gently, gently, gently. Don't snap anything because we're creating leverage by doing this, so. Maybe just a little bit of wiggle wiggle. Little wiggle wiggle. Wiggle wiggle. Wiggle wiggle is a technical term, and I find it's very useful. A very useful technique. I don't want to tear anything. Okay, there it goes. Ooh. Yeah. Oh. Hey, and we're free. Maybe, almost, kind of. There's something. Oh, I missed a screw. This is why we're gentle, because sometimes you miss a screw and you almost tear a cable. All right, let's look at the solder points for the power switch. So I've got 6 solder joints that I need to have the solder removed to get the old switch out and put the new switch in. And I'll remove that solder with this solder pump. Iron's heated up. Just a little bit of solder applied to the tip of the iron. We get the solder pump ready. Melt the solder that's on there and pump. Beautiful. Melt the solder that's on there. And pump. You'll notice that the second solder point that I removed took longer because I didn't apply a little bit more solder to the tip of my iron. Having just a little bit of solder and flux on the tip of your iron when you're desoldering is going to help solder melt. Also, if you're not fast enough, it's possible to apply too much heat to the solder pads and the solder pad will come up off the circuit board. And then you have to fix that with a little bit of wire or something. Now, if you did a great job, it might just fall right out, but you might have to wiggle it a little bit. Again, wiggling is a great technique. Huh. My power switch doesn't quite fit. Now I insert my power switch that fits perfectly, and we solder it in. Alright, we heat the leg of the component and the pad, and then we apply solder, and we heat for a moment more, and we release. Okay, I'm going to plug in my new fancy tip negative power supply and push the switch. There's lights! It looks kind of normal. I like the way this looks. I'll go ahead and unplug it. We'll set that aside for a moment. I'm just gonna clean the control board just with some mild cleaning solution. Don't use anything too toxic because it could wipe off the words and information on the control panel. Got some gnarly stuff here on the back I'll just scrape off with a flathead screwdriver. Disgusting! Ugh. I'm gonna clean up all the solder shrapnel. Gross. Alright, let's take a look at this real quick. Got a little bit of grossness over here as well. Go ahead and scrape that off. Yes, I'm scraping the plastic. I'm not so worried about that because it will be under the control panel and no one will ever know. As long as I don't do anything stupid like record it on video and put it on the internet. New rag, a little more cleaner. Oh, it's thunderstorming outside, do you hear that? So the last person to have this was learning to play keyboard, and they've labeled their keys. I'm going to remove those labels. I think it's permanent marker. I'm going to use a dry erase marker, and hopefully this will get that off of there. So we're going to just scribble on the permanent marker and give it a wipe. And off it comes. I got most of it. There's still a little bit left, but that's okay. All right, we'll do that to all of these. Something I've discovered that's important when you're reassembling this, these plastic ridges that are inside the top case, those have to slot into the backs of the buttons here and here. So we're going to reinsert the circuit board, make sure the power connector goes through, make sure the power switch goes through, make sure that the knobs on this side go through, make sure that the 1/4 inch connectors are lined up and those pass through. All right, that's gone in. Now I'm gonna flip it over. So I'm holding the keyboard like this. I'm kind of letting the circuit board drop just a little bit and then pulling the circuit board back towards the back of the keyboard and making sure all those plastic ridges fit into the backs of these buttons. And the buttons should pop up. They should stick out from the chassis. There it goes. Okay. Now that those are all in place, I can start screwing the circuit board down. Let's put a couple of screws by the buttons to hold that in place. All right, we'll put the rest of the silver screws into the circuit board. Fortunately, the person that sold this to me still had the original cap for the power switch. And this goes right here. And we are going to attach the battery compartment. And put the bottom panel back on. Okay. Let's see if it still works. Will I actually get to play with this now? It doesn't work. It doesn't make any sound. There's no sound in the headphones. There's no sound on the main outputs. There's no sound. I'm going to take a minute, try to figure it out, Google it. We'll open it back up, try to make it work. Turned it on, plugged in my headphones, turned the volume all the way up, hit a key, and nothing. No volume. I immediately thought I had missed something or forgot to plug something back in or broken something while I was working on it, so I took it all apart again and started Googling, and then I found some Reddit articles that were like, oh, check this capacitor, check this transistor, all of that, and I got into the weeds. I forgot two very important words when you're working on devices like this. Factory reset. You just read the manual, or you find a YouTube video that shows you how to do a factory reset and reset the device. Set all the values to normal, to default, and sure enough, it just started working again. It's working. It's awesome. Oh, no way. You check it out, you guys. It's BB-8. Okay, the time has come.
This is how the vocoder works. Does anyone want to tackle? Free tacos. And I can be pitch perfect, I don't have to sing.
Right now, I am not singing. Right now, I am not singing.
Right now, I am not singing. Just hearing the notes in your head make you feel like you have to sing the notes. But that's just not the case.
One last thing to do. I've got a plan for that battery door. I'm really stoked that this works. This is going to be really cool. I think this is going to help me a lot with some sound design and some creative musical projects. I'm not going to be the best one to demonstrate the capabilities of this synthesizer. I will link some videos in the description of people who are better at showing what this is capable of. And I would like you to post some links to your favorite microKORG videos in the comments below. And thanks a lot for joining me, and we'll see you next time.
Audio.